Swayam Prabha. Digital India. Educated India.
Hello friends, I am Harshad, coming from Pune. I am coming from institute called as the Cummins College of Engineering. I think some of the places I have seen from my same college, Cummins. As I said earlier, my name is Harshad and I am saying hello friends. So I would like you to call me as Harshad, not by any prefix or suffix sir. Okay? I think you have done some computer engineering, so you know something like a postfix notation or prefix notation. So I don't want to use that prefix or postfix. You can just call me Harshad. No Harshad sir or sir Harshad. Okay, I am your friend. Today, the next 4 sessions, I am going to talk to you, share my knowledge, my experience with you. I would like you to ask me question than just sitting here and attending my sessions. Don't feel shy in asking question. I like asking questions. Questions are not silly, answers can be. Okay? So my answer may look silly, but don't feel shy in asking questions. That is what my first requirement is. It may happen that I may not be in a position to give the right answer immediately, but I will find answer and get back to you again. Okay? If not possible today, but I will send a mail to you. This is the question, this is the answer. That is the probably right or appropriate answer for it. Okay? So don't feel shy on asking questions. Anywhere you feel curious and you stop or revise something, stop me. Okay? My name is Harshad. You can call me Harshad directly. So let's start with our today's job. Web browser security. That is the first session. Tell me how many of you not use any browser? Not use any browser. Any browser? Desktop or on your cell phone? Everyone? Do you know that the browser is one of the most used application in the IT industry or in software development? Okay? Which browser do you use? Google Chrome, Firefox, Opera. Okay, on cell phone. Okay, any other? How safe they are? How safe they are? Can you trust them? Are you getting my question? Yes. Can you trust your browser? Oh, great, good. So I got to know that people are using some pop-up blocker or ad blocker. What are those? And why you need to stop them? Okay, let me come one step back. Before using your browser, how many of you have changed the default settings of the browser? Using what? Settings. But what changes you have made? But going from normal window to incognito window or private window, we don't require to do any settings. I am talking about some different things. Here you have to just select the private browser or the non-browser. Autofill settings has changed. For what purpose? What is the autofill she is talking about? Autofill facility, passwords. Okay. Passwords are saved. Where? In browser. Means on some machine, right? Cache memory. Burn. Okay, I think I got some fair idea where we are and where we need to go. At the end of this session, I feel you will be in a position to configure your browser. That is our first task, because as I said, whatever operations you perform, let's say you just perform Google, you are typing, let's say, compiler or information security, some data is captured by Google, next time when you come back, you will get a similar kind of information. If you go to Amazon or Flipkart and if you buy some, let's say, badminton racket, the next time you go again on the same site, instead of saying Yonex racket, it will show you Yonex G303 or 302R. So how it knows? So something is getting tracked, some information of user is getting tracked by the browser. Is it safe? Is it good? No. Then it should be banned by system only, directly Google.
That's how they make money, so they might really ban it.
Okay. Actually, this is called as a behavioral pattern understanding, understanding the behavior of a user. Okay. Today, it may not be looking like attack for us, but tomorrow, actually today also, people are tracking you, the attackers are tracking you, the government agencies are tracking you, but they are for legal purposes. Some attackers are doing for some malicious activities. Okay? So we need to handle all those things. How we can do it? We need to come back to our browser security. Do you know why it is required? Because I am using the system that I am using, whether it is not leaking any information about me or my behavior outside, it is in whose control? My control, right? It should be in my control. But as I said, not many people are doing changing in the default settings. So it means you are depending upon the browser settings or the system settings. At the end of our second session, we will come back to system settings. Today we are talking about right now on the browser settings. Let's start with the while doing my presentation, I am using some small words like OAPS, XSS, SSL, TLS, Poodle and all things. So this is the abbreviation list. We will come back to it. This is just for your reference later on. You can see the list that Poodle, Sloth, Crime, Beast, Breach. These words probably you are hearing for the first time, but these are the latest attacks available on our using the browser systems. Okay, what are the contents for my session today? Right, the first session, the security myths. Let's start with that. You can read this thing. This cannot happen with me. Only important or rich people are targeted. Okay. Install the security application. Let's take some anti-malware tool on my machine or anti-blocker on my machine, and I will be safe. I do not need security programs because I do not access unsafe locations. Now, what is unsafe location? What do you mean by third party website? What do you mean by first party website? That we need to look into. I set some strong and complex passwords to my accounts, so I will be okay. There are some password crackers available. They are performing attacks like brute force attack, and using which your passwords can be in front of you or in front of the attacker in no time. I only open emails from my friends, so I should be fine. I have said you are my friend, right? At the end of my session, I will let's say tomorrow morning I will send a mail to you. Just click on it, say feedback, okay, say good morning, I liked your lecture, let's try it tomorrow morning. Don't try it because your friend may be sending some mail containing some URL which is a fake URL. Probably he or she must have got from actually attacker. You are going to click on it, and whatever afterwards you are going to perform any kind of key logging, it will be detected, stored and reported to the attacker, and then bye bye.
Might as well install something.
Yes, possible. The next one is I do not have important information or sensitive data on my system. Why should I worry? Your photos, you must be sitting here in this good campus for last 2 days, taken a selfies and all things, put it on your machine, given to your friends later on or to your parents. If your machine will be stolen, you are going to, let's say, Majestic or to some airport, and your machine somehow got lost, what will happen? Whether that your photos, whether your information, your let's say certificates are not important, they are. So these are some of the myths and misconceptions. Let's talk about information security, what it means. Information security means protecting information and information systems from unauthorized access, use, disclosure, disruption, modification or destruction. Some few months back we have seen attack, WannaCry attack. So how many have seen that attack and why the attack has come, or how it has stopped the working of users?
So it encrypted the system and that system.
Perfect.
Logged it and asked for a
Ransom.
in exchange for decrypting.
Correct. The attack used to encrypt data on your machine. It will be available to you in the form of plain text only if you pay the ransom. If you are not going to pay ransom, then your data, as if it is not taken backup, then we cannot use it again. That is that destruction, or it can be modified data. Web security is a set of procedures, practices and technologies for protecting web servers, web users and their surrounding organizations. Here I am using two words, web server as well as web browser. There are attacks like cross-site scripting and cross-site request forgery, using which attack can be made on web server as well as on the client side. So, and all these things come into picture because of browser also. Web application security is a branch of information security that deals with security of websites, web applications and web services. Okay, so it is not restricted to only application that I am developing a website to that only. I am going to develop some web services, may not be used by me, but because I am the developer or the library developer, I will develop some web service used by some third party or some other users. If my system that I am building is buggy, leaking information, is not having security taken into consideration while developing the software, then that third person or the user will also be in a danger state. The keywords that I'm going to use again and again. First one is called as the threat. It's a generic term for objects, people who pose a potential danger to an asset via attacks. Vulnerability, it's a weakness or fault that can lead to an exposure. Risk, it's a probability that something bad happens to the system or to the organization. I am using a word called as the attack vector, actually a vector. It's how the attack was carried out. Probably you must have come to these three statements many times now last 3 days. CIA, confidentiality, integrity and availability. Okay? So I will not go into this thing, but look at the confidentiality part. What is the consequence? Loss of information, loss of privacy. The next one is a loss of information, that is about integrity, loss of information, compromise of machine. And the last one, availability, prevent user from getting work done. What is that? Preventing user from doing the work?
Barring him from accessing the system.
Perfect. Let's say I am going to send some request to you, or just simple ping request to you continuously on your desktop or on your laptop. Your system will start responding to my ping request. What will happen? I will flood your system by just sending ping requests. Your system is just responding to my ping request. Reply. Yes, I am there. And your CPU and your system bandwidth and all things will be used only for just receiving the request and replying the request for the ping. It's called the ping of death attack. That is the attack on availability. Now, doing this activity, the web browser activity, what we do actually? We are the user. We open the system OS, then we open the browser. You type your URL, Google, Rediff or whatever, or your college ID or ICICI ID, ICICI URL. Then what happens? Then the DNS comes into picture and it finds the corresponding IP address. Okay? Because there may be multiple servers available for the same system. So whatever is the currently available or nearer to you available server will be given a request. Your request will be sent to that server. That is the point number 2. What happens now? The browser has IP and all those things. Data goes to the internet. The HTML data is returned by the server back to your client. The browser gets the information from server in the form of HTML. In browser there is a system called as the rendering engine, HTML rendering engine, which reads that HTML data and shows it for you. Hey, looks simple, right? Now it is this complete diagram, the previous diagram is written in this fashion. There is a user using laptop or system, there is a internet and there is a web server. Very simple thing. Now what happens? When you talk about ICSI or any such systems, there will be, when I want to do some transaction, I need to go to ICSI site, get logged in successfully. Once I logged in, I can see my balance data. If I want to do some transactions, I can do transactions. So what I require? First thing is I require ICSI web server. The next one is the application server, which can do all the stuff for me, and database server where my records are stored, that Harsha has done this changes, this transaction on this date. So I require web server, I require application server and the database server. To whom I am talking actually? I am talking to ICSI web server and not to the application server or database server directly. I am talking to ICSI web server. Now these systems, ICSI or your college or all those things, those are called as websites or web applications. Earlier attackers used to make attacks on these systems directly, because if I can attack ICSI website, I can get thousands of information available to me, okay, and then I can attack individually or whatever. But these system developers are smart. What they have done now? You can see on the extreme right, your application servers and all those things will come into that block. Those are having a boundary called as a internal firewall. After that internal firewall, there is outside called as a DMZ, that is the demilitarized zone. So if attack is happening, the attack will happen first on the DMZ. There is a system admin who can, a security admin who can look at the logs, what are the changes happening, what are the attacks happening, and then he can stop or deny those things. So there is a DMZ. Before that there is the external firewall, okay, and then comes the internet, and then comes to me where I am using my client side system. Tell me whether such kind of internal firewall, external firewall, IPS device, IDS devices are there on my machine, on my client machine. Nothing. Nothing is there. So my right hand side is probably safe. I am not saying 100% safe, but probably safe. But the left hand side, there is nothing. There is no security tool available which can protect the user. Okay? Nowadays you are installing anti-malwares, Kaspersky or McAfee or any other, eScan, Quick Heal, but those are not decide, right? But those are working on signature based databases. If the signature is available, if attack is happening, I can stop. But if signature is not there, then what will happen? It will not be able to detect and prevent it. So that's what I am saying. Right hand side is now looking pretty secure, and that is the reason the attackers trying to access the right hand side or attacking right hand side are becoming more difficult or complex job, time consuming job. So now they have shifted their window from application, web application or website attack to web browser attack, where we are using the web browsers. So here the need is that why I need to protect the web browser. This is a chart. You can see the network vulnerabilities in last 1 year time. The 15% on the extreme left here, 15% are unsupported, which are because of Microsoft IIS, Outlook, Samba, OpenSSL, deprecated SSL. This is a word, right? Remember this word, deprecated SSL, because when you say I want to talk to my Gmail or Reddit mail or ICICI, I always get HTTPS, and when HTTPS is there, then I am safe because I can see the green lock. Wow, happy? I will show you how it is not, we are not happy. Okay, that deprecated SSL will come into picture. Now come to the extreme right. 22% attacks are on configuration. The first statement there is default credentials. If you start your Unix machine or Linux machine, root, admin 123, admin password 1234, username is Harshad, password is Harshad 123, or username is Harshad, password is my mom's name. Okay, dangerous. FTP exposure, HSTS config. Remember this word also, HSTS config. Okay, I will show you why it is required. Expired SSL and TLS certificates, lack of encryption, misconfigured certificates. Okay. On top of that, you can see the words now that actually are written on the first slide. Beast, crime, weak hashing, weak ciphers. Those are contributing for 45% attacks, crypto attacks. This is about network. Let us go to application vulnerabilities, the application that we use. The first one, extreme left top, 29%, insecure configuration, insecure deployment. Below that, 24% are client side security attacks, cross site request forgery, scripting, clickjacking, CORS, HTML injection, DOM security. Now come to the extreme right bottom. 20% attacks are information leakage attacks, default error pages. Suppose you are developing a website for your TE project or BE project, and there is some data is not there. You should get error message, but your error message is showing that this page or this database I am not able to open. So if you are showing that information to the attacker, yes, there is a SQL table, in that SQL database there is a table XYZ, in that XYZ table there is a column PQR. So you are giving this information to the attacker knowingly or unknowingly, probably unknowingly because you are students, unknowingly you are giving this information and the attacker may use it again. This comes, whatever attacks you have seen, there is a system called as a OAPS. These OAPS, every year they publish the top 10 vulnerabilities. Okay? This is the 17th 2017 attack list, top list. A1 is the injection, A2 is broken authentication and session management, sensitive data exposure, XML, the broken access, security misconfiguration, cross-site scripting, insecure deserialization, using known vulnerable components, and insufficient logging and monitoring. There are few things, that is A3, A5, A6, A7 and A10 I have marked with some yellow color. There is a reason. They are repeated is one thing, but these attacks, if you try to stop one of these things, probably other things may be their attack vulnerability can be reduced. Okay? I will show you, there is a graph I will show you afterwards. If you can modify your configuration properly, you can minimize the other attacks. So these attacks that we have seen, again I have the same data but with different part. One is called a server side, other is called a client side. Server side we have seen there are pretty other tools are available which can stop the attacks happening on the servers or minimize the attacks happening on the servers. On the extreme right, you can see the client side or browser securities. There are some red colors. Injection, that is your SQL injection, your command line OS injections will come into there. Cross-site scripting, broken access control, security misconfiguration, sensitive data exposure, insufficient attack protection, and the cross-site request forgery. These are the attacks. Those are also available on the browser side, and how we can minimize or stop these attacks. That is our target. Before going into these different attacks, let us first understand what is called as a same origin policy. Because we are talking about a browser, and browser, what happens on that side? The first one is called as the same origin policy. Our system should adhere to this thing. Under the policy, a web browser permits scripts contained in a first web page to access data in a second page, but only if both pages have the same origin. It's like what I am talking about, same origin, first page and all those things. Look at the line number 3. What is called as same origin? There are two URLs. One is called as the http://example.com, and the next one is http://example.com/settings. The first thing is they are using the same protocol. Second thing is they are using the same URL. Third thing, they are using the same port. Port can be 8080. Okay? Below that, you can see the different origins. Simple. First one is example.com, other is icss.com. So both are different URLs. So obviously they are not same origin. The next one is, you can see the example.com:46557 or 8080. It means the URL is same, protocol is same, URL is same, but port is different. The port number, the server that giving the port to the end user or to the client to access, the port number is different. So they are on the different origins. Okay? Now what we talk about? We talk about that whatever pages I am trying to access or whatever scripts I am trying to run, those should come from the same origin, same protocol, same URL, same port. Okay? Now why it happens? Like we can go from first page to second page which is from different site. It is possible. On a web page, on a web server or website, there is some data which is published by the same service provider, okay, or same service, but there are some URLs given by, put by attackers or by third party systems. And third party, when let's say if I go to Reddit mail, what I see first, there is some box for where I can log in and see my mails, but there are some ads coming, some news coming. The news are not given by Reddit mail, the ads are not probably given by Reddit mail, those ads are, let's say, from Lotto or some other things or Amazon. So those ads, the URLs containing ads are on the page of Reddit mail. I have gone to Reddit mail site, knowingly or unknowingly, I am clicking a URL probably not belonging to Reddit mail. Because of that, if that page, I am trusting Reddit mail right now, but because of knowingly or unknowingly clicked on some URL which is not provided by Reddit mail, may contain some malicious script, and that malicious script will run on my browser now. It may run on my browser, it may take some data from my system and throw outside. So I should trust only the first party. Who is my first party here? Reddit mail. I should not access or open the URL which is from other location. So I need to adhere to the policy called as the same origin policy. Okay? I have said about one word, CORS. This is CORS. cross origin resource sharing. It's a mechanism that allows restricted resources on a web page to be requested from another domain outside the domain from which the resource originated. I am talking to Redip mail, but I am trying to open some another URL, some another page of some other domain. CORS came essentially to eliminate some restrictions imposed by same origin policy, which would block a AJAX request. People have two types. One person say, okay, I allow me to open another URL on another domain. What happens? Myths, no? We have seen the myths. I don't have any data, confidential data on my machine. What can happen with me? I am not rich. Vagere, vagere. So they are in the category of allow cross origin activity. But if you are a security knowing person, then we should stick to SOP, same origin policy. The first line, the absence of an SOP will create chaos, as scripts from any origin will be able to read user data and make requests, perform unauthorized actions on the browser or on the client's machine. How I can prevent? If you remember, I have said when I start my session, I have asked how many of you modified the configuration of your browser. Look at this setting for Firefox: security dot file URI dot strict underscore origin underscore policy. How many of you have known this property? We are engineers, right? Or going to be engineers, and this is our, and I think we are from IT or com background. Engineers, IT or com background, and still we are not knowing about these things. Think about even right now the 4th standard or 5th standard students going to net cafe, doing transaction, doing some net surfing and all those things. Your mom, dad probably not belonging to same our area, they are using the systems. What is happening to those people? We'll come back to you. Let's start out the first attack, the cross-site attack, cross-site scripting attack. Using some asynchronous scripts, Java scripts, we are able to attack the website. There are some, I will send a link to you where you can see the attacks made because of AJAX scripts. Have you seen something like JavaScript earlier? Or okay, after our session I will talk to you. Okay, we can write scripts using AJAX which can attack the web server as well as the client and read some data from the user system and send that data outside. Okay, we will come back to you surely. Let's start with the first attack, the client side attack, which is a cross-site scripting. The steps that I have given, those are in the sequence. The first one is the attacker injects some script in the code on the website code. Okay. Now user using the browser tries to access that page. User tries to access this so-called trusted website. Now the attacker added code will run on the client side and probably will be in a position to take full access of your system. Okay. Attacker has added, see in the cross-site scripting what is happening, the attacker, let's say I am an attacker, I want to attack, let's say my Cummins College website. I write some script on the Cummins College website page. There are some Cummins College student or outside people, they want to look at the admission process right now happening in my Cummins. They click on that site, on that link. When they click on that link, the link contains a page which contains the malicious code that I have written. people are coming to community college for admission. They are opening a page. That page contains malicious code, and now that code will run on that end user's machine. Fetch some data and send it to me, not to Cummins, to me. Okay? People are trusting Cummins College website. What is happening? There is an attack is happening on that machine, on client side machine. This is a cross-site scripting attack. Okay? Now actual attack is made on the server, but to not attack server, but to capture data of the end users. Okay? Phishing, where I will send some link to you, but that link, a friend has sent a mail to you, contains a mail, contains a URL. Not similar to it. Here website is trusted. Here you are talking about mail is trusted. It can be. Yes. It is not actually a phishing attack. Phishing is something like in some mail or some text you are getting, because you are opening that page. You are trusting here whom? You are trusting the website. Here you are not trusting your the trusting website or trusting your friend. That's it. Trusting a mail sent by your friend. But two are different things. Here I am trying to attack using the website, trusted website. Here I am attacking because of trusted mail. Okay? A similar but not same. What is happening here? What is the consequence? A sensitive data leakage. A malicious JavaScript will run on your machine. One of the dangerous activities is keylogging. A software keylogger can be installed on your machine, and then whatever you are going to key in will be recorded, detected, recorded, and send it to attacker without your knowledge. Cookie theft, phishing, privilege escalation. What is privilege escalation? Escalate means go up. You are non-root user, because of running some URL, some script, now you are getting converted into root domain, and then if I am in root, then I can do anything. How will you use Linux machine? Great. So many times what to do? Suppose I want to install a software, we do sudo su, and then give password. What are you doing? You are moving from non-root user to the root user, and if I am a root user, then I can see all the data of other users which are logged to my system. Okay? So that is that privilege escalation. So all these attacks are possible because of the one malicious code added by attacker on the website, trusted website, so called trusted website. I am going to use this word trusted again. Yes.
So the information the user will be adding, it will be providing, that will go to attacker or web server or root.
Attacker.
It won't be going to.
It depends, but what will happen is attacker will stop the data which is private data or needed data to him, and other data he may craft it. Whatever data the end user is sending, the attacker may take that data and pass it on, or some data he will just ignore, just read passively, and that data will go to the client, the website. Correct. That is called the man in middle attack. So the attacker in between can read his data, whatever data he feels important to him, store it, other data will go out. But I am saying keylogging, where when the keylogging is happening, the data will not go to the website now, because I will stop probably going to the website, but whatever I am keying in, the keylogger tool or software that I have developed or attacker has developed will provide some IP address of the site or of the system of the attacker. So the keylog data, the log data which is because of the keylogger will not go to website now, because website probably stopped, or not have stopped the browser also, but because of the code, the keylogger code contains some IP address, to that IP address data will go. So now it will not go to the website, it will go to the attacker. Now the second attack is cross-site request forgery. First one, using website I have attacked the client. Now look at this attack. What is the operation? Attacker is interested in hacking a website. Okay? User is logged in to the website X. Now the attacker is going to attack the user. Now using the user's credentials or system, he will attack the website. So for website, who is the attacker? User, but he is actually the victim. The attacker is sitting somewhere else. That is cross-site request forgery attack. Attacker is interested in hacking the website X. User or victim logs into website X. In between, attacker forces user's browser to send HTTP request to website X. That is, the request sent by user to the website is crafted, is modified by the attacker. The attacker uses this functionality of the website X using the communication between the websites and user. Now the attacker website is also compromised. User already compromised, website also compromised. What are things possible here? The consequences, again sensitive data leakage, key logging, cookie theft, phishing. Attack is made on the website. Now there will be n number of other users who are going to access the website, like cross-site scripting. Now the website is compromised. Now I can make use of the client machines, other users. Okay? The next one, the phishing, what our friend was talking about. The attacker creates a fake website identical to secure website. It looks ICICI, but it is actually LC, LC1 or something like that. Attacker send the URL of the fake website to the user, asking him or her to log into the fake website. The user logs in credentials into the attacker's page. What happens now? The first time, look at the way what happens actually. Instead of ICICI, there is some garbled data in the form of, it looks like ICICI is shown to you. You type your credentials, username and password. Data is not going to the actual website. Data is going to the attacker. Attacker has got your data. Okay, and then he will send, as you are not able to, and then he will send some fake page to you, or you will get a page request, that is the page not found, and you will say, what happened? I am trying to access ICICI but page is not found. So again you type again ICICI, and the next time your page comes correctly. In between you have referred the fake website provided by attacker, which is looking like ICICI. Now your data, your username and password is with the attacker. If somehow he is able to get your cell phone number also, for any transaction nowadays, the bank facilities, they provide a facility called as a OTP, one time transaction password. They send up OTP to you and they ask, enter this OTP. Now look at the thing, the attacker is knowing your username, password. Attacker is also getting the OTP because your cell phone is compromised. Data coming to your cell phone is also available with the attacker. He is having the OTP. Now he is able to do any and all transaction. Bye bye. That is sensitive data leakage. Now let's come to our very famous, we talk about HTTPS, green lock is there, wow, good. Insecure data transfer. User transmits data to the web server in plain text format. Attacker sniffs it and reads it. Attacker hijacks user's web session using the sniffed data. Why it is possible? I have said earlier that remember one word, HSTS, Remembering it, let's talk about it. Okay, what are the consequences first? It is sensitive data leakage. There are some different attacks possible because of this insecure data transfer. The attacks like Beast, Crime, Lucky 13, Time, Breach, Poodle, Frick, and MITB, that is a man in the browser attack. We are knowing MITM, that is a man in the middle attack. It is a MITB, man in the browser attack. Let's talk about these attacks one by one. Poodle, it's a padding oracle on downgraded legacy encryption. It's a downgraded legacy encryption. Okay? The Poodle attack is in a man in the middle exploit which takes advantage of internet and security software clients fallback to SSL 3.0. Hey Kai, what is this SSL 3.0? Perfect, secret software layer. When you are on HTTPS, you are getting some green lock and all things. So how they are provided? Those are provided by two things. One is the SSL, other is the TLS. Okay? The earlier things are SSL 3.0, SSL 1.0, 2.0, 3.0. Now TLS 1.0, 1.1, 1.2, and so on. So your browser is showing that it is SSL. It is running the HTTPS URL, but the system that it is using, the SSL or TLS, is downgraded, is buggy. It is having some bug in the code. It is already broken. What will happen? You feel ki okay, I am having HTTPS, but the code is already broken. The attacker is having the facility to read that SSL 3 kind of transferred data. So for you the data is encrypted, but it is encrypted using that SSL 3.0 kind of protocol. The protocol is already broken. The attacker is knowing how to break that code and read the data from encrypted data to plain text, and if I have plain text data, then I can read it. That is a downgrading of from TLS 1.2 or 1.3 to SSL 3.0 or TLS 1.1. It's simple. Let's talk about what is that downgrading. You must have used some word, some function like strcpy, string copy function. Okay. There is a function called as strncpy. Have you come across that thing? strncpy. Copy the first n characters. So what happens? So if I have strncpy, then I can copy, let's say my buffer is of size 10, I can say copy only 9 locations or 10 locations. strcpy can allow me to go to more than 10 locations also, 10 data also elements. Okay? So can you think about that? strncpy is better suited than strcpy so that buffer overflow attack can be mitigated. We will talk about buffer overflow at the end in my probably third or fourth session. We will see the same example. So strcpy and strncpy, where if I use strcpy, the chances of doing the buffer overflow attack are less than my strcpy. Similarly, if my TLS 1.2 is here and SSL 3.0 is here, if my settings of browser are converted in such a way that from TLS 1.2 it comes to SSL 3.0, which is already broken, so attack may be possible. That is, I am moving from TLS 1.2 to SSL 3.0. That is called as the downgrading of the system, downgrading of the protocol, downgrading of the implementation code. Because of that, this attack is possible, a Poodle attack. How we can prevent? Disable SSL 3.0 on the client and the server side. There is a next attack called as a freak attack, that is the factoring RSA export keys. I am sure you must have come across something like public key encryption. So I think you must have studied something like RSA things. So what happens here? The server is having RSA cipher suit. The client offers that, client also allows, or client is saying okay, I am going to talk to you using RSA encryption. Client is also, the server is also saying, talking in the RSA kind of stuff only. now if this RSA export key is actually broken now, if it is used, then this RSA downgraded encryption facility allows the attacker to read your data. Earlier it was SSL 3.0, now I am talking about RSA export keys. Those are also getting broken, those are also can be hacked by the attackers. So you look, yes, I am using RSA, all the things, but still you are in a danger state. There is one more thing. On your Linux machines, probably you must be using some OpenSSL tool. Okay? For what purpose? Something like you are doing, you have some file, you want to encrypt that file, or you have file and you want to hash it. So you say MD5 use some file name, or SHA1 some file name. That OpenSSL tool, the library that you have is already broken. Suppose you are feeling that your data is encrypted and cannot be read, read by the attacker, but your tool that you are using is already in a dangerous state, is broken. Can you trust the output? Cannot. That is a freak attack. The latest one in this series is sloth. Security losses from obsolete and truncated transcript hashes. People are saying we are using TLS 1.2, but TLS 1.2 is also now broken. Some work is going on TLS 1.3. Already now people have started working. TLS 1.3 will be available soon with all the browsers, Chrome, Firefox, all the things. But in Firefox right now, it is still in the probably in a beta version, not yet added with the client side with the user like us. This is sloth attack. The next one in this list, browser attack, is called as the WebGL attack. Most of the users nowadays, they are running with the graphics card on their laptops. The graphics card driver, they are having some bug, they are having some leak. So using that leak device driver, attacker can attack your system and send your data outside. Even it can perform privilege escalation attack. We are talking about browser. I am trying to open some page which contains some graphics data, image or video, all these things. To run that thing on your browser, I require to take use of my graphics card. My graphics card requires to run the device driver. The device driver is buggy, and now the attacker is able to read your data, send it outside, or perform privilege escalation attack. WebGL, simple enough. Okay, let's talk about this attack that we have seen. I have shown only 5 attacks right now, but these attacks, how they are placed. The first topmost part is, you can see 37% attacks are information leakages attacks. Then you can see cross-site scripting, content spoofing. The next one is insufficient transport layer protection. But about SSL, TLS, that thing here comes here. If you have machine with you right now, you can start a browser. Let's go to these sites one by one and see whether your browser, they are configured correctly or not. Okay? Let's do some hands on. Let's see where we are. If you understand where we are, then probably we can understand where I need to go, and from my state X to state Y, if I want to go, what changes I require to make easily. Okay? Because we are not in a position right now to modify Firefox code or your Chrome code. Let's go to the first site, browserspy.dk. Yeah, take your time. browser spy.dk. Huh? Shabash. You want started? Okay, so you can see this browser spy.dk site now. It is in front of you. Extreme left side, you will find some names like cookies, CPU, cursors, date time, DirectX, do not track, etc. etc. Let's click on the browser. Wow. The browser that I'm using, that information, the information of my browser is in front of me. I'm accessing browser spy.dk. I'm clicking on the URL published by browser.spy.dk. When I click on it, I'm getting the information of my browser settings. I'm using Firefox right now. You can use Firefox or Chrome, whatever. Finished? ठीक है? I'm not saying use only Firefox, you can use Chrome also. You can get the same kind of information of your system. You will not get same information because using Firefox. Your Firefox may be having different version, they may change. Finished? Now go down and there is a option called as the cookies. Look at this data. What is showing? Cookies enabled. Yes. Actually, there is no information which cookies I am talking about. Whether the first party cookies or third party cookies. We will see that thing afterwards. Okay, it is saying cookies enabled. So it is saying yes. So cookies are enabled. JavaScript cookies supported. Yes. Go down. There is a HTTP only cookies supported. Yes. You can see here the current cookies. When I am talking to browser spy.dk, what is the cookie that is generated is showing here. Now let us go down and here click on JavaScript. On the left hand side there is a URL called JavaScript, click on it. See what happens. What is showing? Tell me about your machine. Don't look at this code also. It is showing something like the generic JavaScript is supported. Means what? It means the web page, if it contains JavaScript, can run on your machine knowingly or unknowingly on your machine. Knowingly or unknowingly to you. Okay? And when that JavaScript will run on this machine, containing some malicious code, it will do some activity, take some data and send it outside. It is that dangerous activity, the JavaScript. Default settings, are you getting me? Hey, default setting. Let us go down. Oh, sorry, here. There is an option called as a do not track. Please click on it. Read the first line basically. Do not track is a technology that enables user to opt out of third party web tracking, including behavioral advertising. At present, a user cannot opt out of many of the hundreds of tracking services and advertisement networks. Those that do not that do allow opting out, each requires setting an opt out cookie. Ignore the last line. Read the first line. Do not track is a technology that enables user to opt out of third party web tracking. Right now, this browser that I am using is not configured that way. So, third party website can track me. One more thing, even if I say okay, do not track me, it is not mandatory for the other system to obey or to understand what I am saying. I am just trying to say कि बाबा थम्बो, I don't know track, ठीक है, but it will stop always, ऐसा नहीं है, it will not happen. That is the next line that it has written, the line number 2, it has written that line, ठीक है, it is just for my saying okay, I have said do not track. So this is the first website that you have seen, ठीक है. Let's go to second website. Are you getting me? Are you enjoying? Yes. Great. So let's do the next website called as panopticlick.eff.org. This site will help you to identify or fingerprint your browser. Okay, let's go to the website and say test me. It is showing testing your browser. Great. So this current browser settings, what they are showing? Use your browser blocking tracking ads? No. Use your browser blocking invisible trackers? No. Good. Does your browser unblock third parties that promise to honor do not track? अरे कुठंच नहीं है, there is nobody is saying yes. Everything is no. Great. Does your browser protected from fingerprinting? No. Go down. There is a URL, show full result of fingerprinting, and you can see your browser details there. At the end you will find your browser fingerprint appears to be unique among some number in the past 45 days. Currently we estimate that your browser has a fingerprint that conveys at least 20.69 bits of identifying information. So your data sent by browser outside is containing some data, is 20.69 at around 21 bits, using which you can be uniquely identified. What should happen? Ideally, what should happen? You should send less number of bits or more number of bits. Think on it. This is a question. I am going to ask the question after I will find the answer for you from you at the end of the session. Okay? Whether you want to minimize the number of bits or we want to increase the number of bits. Okay? Let's go to the next website. https://sslabs.com. Okay, so you are getting this Qualys site, and the facility is there. You can test your server or test your browser. Right now we are not having a server, so we are using the browser. So test your browser, and this setting will help you to check whether your browser is in a position where attacker can make freak attack or poodle attack or logjam attack. Probably your firewall is restricting you. Okay, doesn't matter. When you go back to your place, check it out. Okay, we need to configure your browser, modify your browser in such a way that it will be not allowing the attacker to perform poodle or freak or logjam kind of attacks on your system. Okay, you want to try other things or you want me to move on? Okay, so let's move on. You can see these sites later and check your browser settings. Okay. I think the sites will be available with you. Okay. Now I am showing the window where you can configure your Chrome, but this is not the window I think you have seen on your machine. You are watching the normal window that you have, where you can type your URL and see your data and then go to properties or tools options and then see the settings. I am showing you some different way to configure a browser, because those settings which are provided on the front side, it is for normal user. We are engineers, we are security experts, we are going to become security experts, so you should go to such kind of locations where we can modify your browser appropriately, recommended settings we should perform. So for Chrome, you can go to Chrome://flags, and you can see a window there like this, and then you can modify your settings more better way than the options provided at the just tools section or options section. Okay. This is for Internet Explorer. How you can go there? I have given the path also. Go to, press Windows R. There is a Windows button on your keyboard. So press Windows R, type gpedit.msc. Then you will go to the user configuration, then administrative template, then Windows components, and then in that there is a Internet Explorer. ठीक है. I have given path here also. Windows R, type gpedit.msc, you will get a user configuration. Then you can see here there is a user configuration here. If you click on it, then there is an administrative template. Inside the template there is a Windows components, and inside that there is a Internet Explorer. I will show the third one with respect to Firefox, and I feel that is pretty simple than doing all those things. If you have Firefox on your machine, please start it. In this URL bar, just type about:config, about:config. Press enter. You will get this window. What is showing? This might void your warranty. Changing these advanced settings can be harmful to the stability, security and performance of the application. You should only continue if you are sure of what you are doing. Yes, we are sure. I will be careful, I promise. Click on it. And you can see this big list where your browser, Firefox browser settings are available here. The left hand side you will find the property name or a parameter name of Firefox browser. On the right hand side status, it will show default or user modified or something like that. Type boolean or integer and so on. Value true, false, all these things. Okay. Let's go to the first property, cookies. Okay. We are very much hearing the word cookie. Let's see what is cookies. Type cookie here. There is a property called as network.cookie.cookieBehavior. Okay. Network.cookie.cookieBehavior. Right now it is default configured, integer value is 0. We can modify it. There are 4 values. We can take one of the values here. What are the values? My next slide will show you that thing. But this is the way we can configure the Firefox. Just go to open the Firefox browser, go to about:config, and you can see the list of properties. You can modify them, modify these properties one or more depending upon your need or your security level that you want to achieve. Okay? Security level that I want to achieve may not be the same level that you want. Okay? That is the reason they have given the default settings, so that they are in the hands of user. If user wants to be more secure, he need to modify the settings himself or herself. I will show you that. I'm coming to you. Okay? So these are settings how we can do it. Let's see now these values. I'm talking about Firefox. The case study that I have taken right now is Firefox. The first property that I have listed here is, or let's say go to the third property, cookie behavior. Okay? What is the meaning? Track user across various websites. 0, which is the default value. What is showing? All cookies are allowed. What is the recommended value? Cookie from originating server is allowed. Cookie from originating server. There are 3 values, 0, 1, 2, 3 are the values for cookie behavior. This is the recommended value. That I should accept cookies only from the first party website, not from any other website. Okay? The next one is called as cookie lifetime. What is the cookie lifetime? By default, it is originating server sets. So whatever server has set, that is web server has set, the cookie should reside on your machine. After that time cookies are enabled or cookies will be available on your machine. What should be the actual value? When I will terminate my session, my cookies should be deleted. See the difference? There is a fifth one is HTTP referrer header track users browsing activity. आठवत I have said something like do not track. ठीक है ना, अपन बघूया ते. HTTP track header. What is the default value? Send HTTP referrer header. And what is the expected value? Do not send HTTP referrer header. Are you getting me? So these are the, see, this is for Firefox. So similarly you need to go to Chrome or IE or Safari or any other. Look at the properties, understand what that property means, what is its corresponding default value and the recommended value. Based upon that, you need to take a call how you need to configure your browser. It can be IE or Firefox or Chrome, Opera, whatever. So because the property names in Firefox, they may or may not be matching with the Chrome. So you need to study all these properties for particular web browser and then configure accordingly. For end user, this is the information given by Firefox. Okay, what is showing? Tracking, tell sites that I do not want to be tracked. History, Firefox will remember history. These are the default settings. These are the default settings, and I have shown you the previous slide where the settings, expert settings are something different. Now look at these URLs, these properties. These properties are talking about the properties that related with the attacks that you have seen. What are the attacks you have seen? Cross-site scripting, cross-site request forgery, WebGL, insecure data transfer. So these properties are related to those attacks. So first one, cross-site scripting attack. What should we have? What should happen? Security.csp.enable should be true. Default true है, default is true and expected has to be true. Now you may say कि why I am saying it is true and again I am saying it should be true, because we can write a small script that can change this csp.enable to false. What is CSP? We have seen one property SOP, right? What is SOP? SOP, the first part that we have started with, same origin policy. If we want to use that same origin policy, the another thing that we require is CSP, content security policy, CSP. So this security.csp.enable need to be set to true. By default it is true also, but user may knowingly or unknowingly set it to false, or some script running on the web browser on the system will modify it from true to false, and that will be in trouble. The next thing is network.cookie.cookie behavior should be set to 1, so that only first party cookies will be residing on your machine. Request forgery, the send referrer header right now value is 2, the recommended value is 0. The next one is that insecure data transfer. The property here is SSL/TLS. The property is security.tls.version.max. The current value is 3. The current value is 3, which is reflecting to TLS 1.2. And I have said earlier, TLS 1.2 also found to be broken. People are working on TLS 1.3. When TLS 1.3 will be available with the systems, this value will be changed to 4 for Firefox. ठीक है. WebGL, your current WebGL property is showing false. Actually is WebGL.disabled false, means WebGL is enabled. WebGL is enabled, it means the device driver, the graphics device driver which may be buggy running on your browser can allow end user, the attacker, to perform privilege escalation on your machine. So this value need to be converted to true. Information leakage, somebody has said earlier, autofill. Look at this, information leakage, browser.formfill.enable the default value is true. So whatever data is showing, it is getting stored on your machine. Okay? When your browser is closed, when you again open browser, again the data will come back. It is stored on your machine. The ideal value should be false. But are you with me? If you remember, I have shown you OAuth's top 10 security list, that attack list, and I said there are 4 things which are in yellow color. If you modify one thing properly, probably you can mitigate or minimize the different attacks. Exactly that thing I am showing you here. This is a web browser based attack tree. At the bottom, you can see the security misconfiguration. There are other attacks, right? So there are arrows. Start reading this diagram from bottom up. If I can configure my browser correctly, I can stop my WebGL attack. I can stop or mitigate or minimize cross-site scripting attack, a client-side cross-site scripting attack, SSL TLS based attacks. If I can handle SSL TLS based attack, it means I can handle man in the browser attack. Are you able to understanding it? And RSA factoring 1.2 shifted to SSL 3.0 or RSA shifted to downgraded RSA. That is man in the middle attack. That can be mitigated or prevented if I configure SSL correctly. If I can stop MITB, I can stop or minimize sensitive data exposure. The middle line, if I can configure my browser correctly, I can reduce the chances of CSRF attack, that is cross-site request forgery. That can mitigate or minimize phishing attack. And if I can handle WebGL, cross-site scripting, sensitive data exposure, MITB, probably I will be in a position to stop privilege escalation attack. I am not saying I will stop 100%, but I can reduce the chances of attacker attacking my system. Okay? Look at the first default settings and now settings that we have configured correctly or recommended settings. They are different things. We need to understand this thing now. Based upon my understanding, I have prepared some equation for how I can modify the browser correctly or appropriately for recommended settings. I have taken only the 4 properties: CSFW, cookie behavior, SSL, form fill and WebGL. If I just look at these values, this is the considered default, the browser recommended and considered recommended. For these settings, what I have done is I have just performed binary verification, that is true or false, 3 or 0, 1 or 0. Okay? And using that idea of binary conversion, the binary conversion you can see here. If I say browser recommended is 1, consider 1. If browser recommended is 3, I have considered is 0. False is 0, true is 1. Okay? Instead of, because each property is having different values. Let's say it can be true, false, it can be 0, 1, it can be 0, 1, 2, 3, 4 and so on. So I have just considered into good value or a bad value. 0 is bad, 1 is good value for me. So based upon that understanding, I have prepared this table. There are 4 properties, right? And each having 2 values, 0 or 1 or true or false. So it gives me 16 elements, 0 to 15, that is 16. Then these properties 0 to 15 properties, I have labeled them, whether it is a bad property or it's a bad setting or a good setting or a medium setting. So you can see here, B stands for bad setting, G stands for good setting, M stands for medium level settings. Are you with me? There is only one setting in between, that is setting number 9, that is 1001, that is cross-site scripting is set correctly, SSL set to 0, F is 0 and W is 1. If I can get this setting only, then I will say that my browser is configured in a good security state. Based upon that, the equation that is getting formed is given below, that phi equal to C and not of S. S is 0, right? So S0 means it is not of S, and F is again 0, I want it 1, so it is not of F, and W, that is W is 1, I want value of W to be 1. I can show you again. You can see the values at location, read the question number, index 9 data 1001, right? C1, I want C1, I want S1 actually, then F and then W, so I should get that value. So the value is coming as, the equation coming is C and negation of S, that is negative value of S, and negation of F and W. While performing my operation, my data, my result preparation, what I done, instead of 4, I have considered 21 properties, and if I see 21 properties and then raised to 2, look at the data available, and then performing labeling good, bad or medium using human way or using machine way. There is a tool called as the Veka. I have used the tool called as Veka to perform training as well as testing the browser settings. Based upon that, I can show you my result here. That is the Veka classifier using SMO and using naive Bayes techniques. Based upon this understanding, labeling correctly, I have prepared my own Firefox browser add-on. What it does, it has two main components. One is called as a SS, stands for security settings measurement module, and security setting configuration module. So first thing is, it reads the current settings, compares with the recommended settings, tell user how the browser is currently configured, it is in a bad state or a medium state or a good state, and if user says okay, I want to go to good state, configure, then my system, my add-on configures it, the browser. How it actually works, the web browser, my add-on first reads the configuration settings, it is having the analysis engine which performs the checking with the Veka tool, that whether my settings are in a good or bad state or which state. Based upon that, the recommendation is done to the user. If user says okay, I want to modify to the good state or whatever state I want to go, you can modify, and then using the modify controller we can modify the settings of Firefox browser. This is a screenshot of the browser that the add-on that I had developed. Why I am saying this add-on, I am not saying to sell it, but you can see about.config, right? About.config is showing the property name, and then user requires to go to some another site to see what is the property name, what it means, what are different properties, and how I can set it. But this add-on not only gives me the property list, but also gives what that property means, what are their corresponding values, what is the current value of your browser, and what should be the expected value of your browser. So this add-on that I had developed gives that facility to the user, and based upon that user can modify it. My tool gives the facility. Now what is remaining in my work? Right now I have performed configuration management, but other things can be a script based attacks can I minimize, that need to be still to be done. The spoofing attack called as a DNS attack, if you remember, started with the first diagram. User types the URL in the browser, it goes to the DNS. If there is an attack called as DNS poisoning, the attacker can poison the DNS so that instead of giving the actual ICICI IP address, it will give me fake address of ICICI, and I will go to that site looking for ICICI and do transaction. Instead of phishing using the URL, it is a phishing basically using the IP address changed by the DNS. So can I stop it? So that is my another work that I'm looking for. The next one is privacy protection. Even after doing all these things, still I feel privacy has not achieved to the level that I want. the other point that I want to perform is to develop a Firefox add-on that can intercept HTTP or HTTPS traffic originated at the browser side. Now why I want it? Let's take the user is doing some HTTP traffic. He wants to open ICICI, and instead of typing https://www.icici.com, he just types ICICI and press Control Enter. It opens the site with HTTP. But when the site is open HTTP, it means the transaction happening is in the plain text. It should be in encrypted text. So how can stop it? That is the work. The next one is modify browser settings dynamically for that specific web activity based upon the URL. Let's say what I do right now is static. I make the modification on the system, it remains permanently till the next modification is not done. For Google, suppose I want to do some searching, then whether I require these settings, privacy setting, do not track settings to set to 1, SSL set to 1.3, do I require? It is just surfing activity. I probably don't require that much of security level. I am doing ICICI transaction, I require more security. So based upon the URL that user is trying to access, can my browser get configured automatically at runtime? मजा येते ना? तसं व्हायला पाहिजे. That should happen. Now one more thing I have said earlier called as a HSTS. Right now our HSTS is enabled. Almost all the browsers are configured to allow HSTS. What it does, even if you type HTTP, if you type ICICI at Control Enter, it converts into HTTPS. If you want to try it right now also, it goes to HTTPS by default. This should happen. Okay? Google, it also goes to HTTPS. For Google, do I require to HTTPS? Just try it. You can just type Google and press enter. It start with HTTPS Google. So this should happen at runtime based upon the URL the user is typing. Okay? And one more thing, one more work I would like to take up is study the performance of the browser. If I do all the settings, if let's say to open a Google website, I take let's say 1 millisecond right now with the default settings. If I do my settings, recommended settings to make my system secure, if it takes 1 minute, who will use my system?
What is the name of that Firefox extension which you had developed?
It's an add-on.
It's an add-on.
It is not on net right now. On net means I have not published it because some work is pending, so it is not yet published fully. But people in my university they have used it. Where I am doing my PhD, people have used there, and I have shown you. Okay, I have shown them how their configuration looks like, but it is not yet published. The work right now still I am saying pending is after doing my settings or recommended settings. I am not saying my recommended settings. If I take 1 millisecond today right now and after settings it takes 1 minute, people will not use it. People are more interested in getting result fast, quickly than security. Actually security should be the prime importance, but again depends. So for Google surfing, do I require that kind of security? Depends. So let's quickly summarize what we have seen today. Misconfigured web browser plays a vital role in client-side attacks. This misconfiguration may arise due to default browser settings, user having less or आता काय वाटतं तुम्हाला? What do you feel now? Less or no adequate knowledge of secure browsing. We propose a framework to detect and correct configuration settings, setting errors of the web browser. The present work right now what I have done is on vulnerabilities like cookie theft and SSL bit attacks. Do you know why I come here to deliver lecture? It is because of my first thing is because of my mentor Dr. Arti Dixit madam. She said ki this is a good opportunity, you can showcase your work. The second thing is awareness. Around 30 students right now here, 20, 25, whatever. So if those students will go back, they will inform at least one person if you understand it. First thing you need to understand, then you can pass it on. Then it's a multiplying factor and people will get educated towards secure browsing. The first one is the browser, the book that I would like you to read is the browser hackers handbook, where JavaScript attacks, how we can handle, the Ajax attack, how we can handle, all those things are given in detail with practical demo. Type this code, run this code, what happens, see it. The next line is very important, take control of your online privacy. If you are opening Gmail and at the same time you are opening your YouTube, whatever YouTube videos that you have seen till date, good or bad, whatever, those are available in your history. If somebody gets your password, can see how you behave. So you are giving your behavioral pattern in the hands of that person. So take control of your online privacy. Read this. The privacy.net analyzer, the last two URLs that I have shown you, you can go to these URLs. Browserspy.dk, already you have seen. Panopticlick, you can see the fingerprinting. I haven't got answer yet regarding what should be the fingerprint, should be minimum bits or maximum bits. Answer don't give me right now, read tomorrow or mail me. And another URL thing is how is my SSL, that is very important URL that you need to look at. These are the references that I have used to prepare these slides. This is the last one, that is 2018 vulnerability statistic report. Go through this report. Every year ASCAN, White Hat Security List, McAfee, Symantec, OAPS, they publish the quarterly or yearly the vulnerability list, the attacks, commonly attacks, the top 10 attacks, top 50 attacks, top 50 applications which are attackable. All these are available on these reports. If you can understand these reports, then probably we will be in a position to say, okay, what is happening in the market? What kind of tool, what kind of software, what kind of policy is required to mitigate these attacks? Thank you. That's it from my end for this lecture, this session.